This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 64. I hope everybody's having a great summer and you're staying well. Today's presentation, utilizing satellite imagery to enhance monsoon operations for Southeastern Arizona, from Jeremy Michael, meteorologist at the Weather Forecast Office in Tucson, Arizona. Our facilitator, Randy Bowers, meteorologist at the Weather Forecast Office in Norman, Oklahoma. Just a few reminders before we get started today that the session is being recorded. There'll be an opportunity for Q&A after the presentation. Please use the chat to ask your questions if possible. We're always looking for future presenters, so if you have an application you'd like to share with your colleagues in the field, please get in touch with us. And if you're looking for training materials, please contact Brian Mata for information or questions regarding that. Thanks to the Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer in the GOES-R and JPSS programs, for their support of the Satellite Book Club. And thanks to all of you for being with us today. Just one announcement before we dive into the presentation, that we are looking for some volunteers, mentors, subject matter experts, and judges for a GOES-R program and NOAA Center for Earth System Science and Remote Sensing Technology GOES-R Hackathon that's occurring September 24th through 26th, 2021. Students from the 6 CESRIST universities will virtually compete in a weekend-long event to develop interdisciplinary solutions for using GOES satellite data. So if you'd like to volunteer for the event, please get in touch with goesr.hackathon@noaa.gov, and I think you'll see some links there in the chat room if you're interested in volunteering or you're just interested in what it's all about. So without further ado, I'd like to introduce Jeremy, a meteorologist, as I said, in Tucson. Before arriving in Tucson, he grew up in Berkeley Springs, West Virginia, attended the University of North Carolina-Asheville, where he completed an atmospheric science degree, and a love for mountain and fire weather drove him to Elko, Nevada. A couple of years, he moved east to College Park to work for the satellite analysis branch within NESDIS. And after a year of valuable experience with satellites, he went back to Elko for a short time before landing in Tucson. He was able to become an incident meteorologist and air resource advisor and supported a number of fires across the western United States. So Jeremy, looking forward to your presentation of the Satellite Book Club today.
Thank you. I appreciate the introduction, and thank you everyone for taking time out of your day to attend this presentation, and really excited to share this, briefly about myself. Is, some misconceptions about the monsoon. I personally always thought, my mind went straight to thunderstorms and flash flooding and lightning and things like that. But when I moved down here and started working in Southeastern Arizona, I realized that the monsoon is so much more than just thunderstorms. There's a lot of unique phenomenon that I really had no idea that some of this stuff occurred down here. And while some of it may not have significant impacts, it still does show up, and it's something that we need to monitor. So I'm going to go through not any one case today, but I'm going to go through a kind of a plethora of different areas, and just briefly a few of them that I'll cover is, it's not just thunderstorms. The beginning of the monsoon, we deal with heat, and it's a dry heat until it's not, as we kind of joke around. Come July and August, and especially this year, it's been very hot and humid. Oftentimes dew points are in the lower 70s in the mornings, and much of the day is in the 60s, thanks to a very active monsoon. Of course, there's dust, there's suboobs that make national media coverage, it seems like, every year when they roll into Phoenix. We actually had a rare one roll into Tucson this year. Fire, I'll briefly touch on that. There's been a lot of presentations looking at the applications of that, so I'll just briefly touch on some of the topic, some of the ways we look at that here. And more importantly, we use satellite a lot here with smoke and air quality to support our local partners, as well as thunderstorms, and we'll get into a little bit of the tropical aspect of what we can see here in Arizona. But I wanted to share this graphic. John Gluck put this together, our climate expert here at Tucson. monsoon rainfall for Tucson, just to show how crazy of a year it's been. You can see 2021, we're at 11.86 inches. And it's quite possible with maybe a tropical event or two in an active September that we could make a run, if not eclipse the all-time wettest monsoon for Tucson. So quite impressive. There's many areas in Tucson that actually are approaching 15, 17 inches of rain for the monsoon. So that's really crazy to think about when much of that has fallen in July. So, you know, briefly looking at wildfires, the fire RGB, everyone has kind of seen that. That's in the lower left-hand corner. These were two of our large fires. They were actually in Phoenix's area of responsibility. It was the Telegraph fire there farthest left, and then the Mezcal fire on the right. And just showing, you know, some of our large fires. We love the fire RGB. We heavily utilize that. Something that I was involved with, working with a number of people in Elko, where we expanded this hotspot notification tool that I think actually came out of Norman. We expanded it down here, and we heavily utilized the RGBs as well as shortwave imagery to look for hotspots to alert our local partners. So we work closely with Tucson Interagency Dispatch Center. And I thought this was a neat case here. You always hear about 15 acres is what you need to see a fire signature, but sometimes it can be much less than 15 acres due to the intensity of the fire. And Thatcher, Arizona is unique as the Gila River runs through that area. And there's a type of vegetation called salt cedar, and it's very flammable, burns high intensity. And this was quite a small fire, but you can see in the corresponding shortwave imagery, it put off a pretty good hotspot. And we were able to alert, now it was in a population center, so the dispatch center knew about that before we let them know, but really unique application of using SnapMap too, if anyone's never ever really utilized that. It helps us a lot out in our rural areas. People take pictures and videos, and we can kind of look at that. And so that was a great little case to look at the fire corresponding with the shortwave imagery. And, you know, moving into smoke and air quality, we have a close relationship with the Pima County Department of Environmental Quality. And ozone exceedance days are important because they have to be recorded with the Environmental Protection Agency. And not every day is at fault of various activities that happen in Arizona. When you have wildfire smoke, that can enhance the ozone. And so we try to help them. Anytime there's an ozone exceedance day, they'll reach out to us, and then we try to provide satellite imagery. I know Ken Drew is our morning coordination meteorologist. He likes to do backward trajectories to try to figure out, okay, can this be attributed to smoke? And then we'll put together a little package for them, and we send it off to them to help our partners. So that's one of the ways we, you know, utilize satellite imagery. A lot of times the true color is really good, especially sunrise, sunset, when we can really see that smoke. But of course the classic visible red band that we can use as well. But true color definitely helps a lot, and it can helps us validate what we're seeing in the models. Moving into kind of a lot of people's favorite, it gains national attention. It almost seems like every year. We're coming out of a pretty significant drought. We had quite a few dust events this year. Unfortunately, they can be really tricky to see at times because when we have these thunderstorm complexes, we usually have significant debris clouds and anvil shading and anvil clouds that move across. So we actually rely on spotter reports and radar to really detect these dust events. But here was one, and thanks to NWS CWSU in Oakland for, I found this on their Twitter page. It can be a little tricky to go back and find some of these events, but this was a classic large haboob that moved through the Phoenix metro area a few years back. And it just shows that if we can actually get the outflow boundary running ahead of the convection, that we can actually see these and track these quite well. But of course, we could have been utilizing dual pole and seeing that on the correlation coefficient showing up quite well. But I just really wanted to show this, a very impressive dust storm. And then when these sometimes initiate, they can get so much momentum, they'll move all the way into the lower deserts, out into Yuma, and even make it into Southern California, which is really impressive. So I also, since we're talking about dust, I figured let's just cover everything. Not typically associated with the monsoon. It's usually pre-monsoon, late spring, but we can get these synoptic and channelized events. And what makes us really worried is the channelized events. There's a number of dust source regions, whether it's agricultural, farming. We have a lot of playas, and you can see the picture on the left. This was what was being seen from the Arizona Department of Transportation webcam at San Simon. And then on the corresponding dust RGB to the right, you can see the large plume of dust. And what we found is when you start seeing bright pink like that, you're starting to have visibility impacts, and you can match it up with the webcam. I mean, if you're driving along the interstate there, you're going to go into a significant reduction of visibility, likely below 1 mile. So that's a day where we were able to issue a blowing dust advisory, and satellite imagery and leveraging webcams and all the tools that are available to us really helped our operations that day. And also this can happen during the monsoon if you get a microburst directly over the Wilcox Playa. We're always watching for that, and that has happened a couple times this year. So another way we can use the dust RGB, but again, it's a little tricky because usually we have a significant debris clouds covering our dust. So moving into Gulf moisture surges. I never really heard about this until I came down here. When I was in Elko, these mattered, but we really just called them monsoonal moisture surges. Every once in a while, they move up the Colorado River drainage, and they could actually push into southern Nevada. And I know Vegas, I'm definitely interested in them, Phoenix, and pretty much all of the desert Southwest. But what I have here is a 4-panel. You have your bottom left, upper level, down to mid-level and lower level water vapors, which really come into handy. And then in the bottom right is precipitable water from GOES 17, the total precipitable water. And in the red circle, you can start to see the initiation of a Gulf moisture surge, and evident by the darker orange. And the purple is well over 2 inches of precipitable water. And the reason that's happening, that was taken last week, or the week of the 19th, and there was a tropical system down there that helped initiate that Gulf surge. Why we care about Gulf surges? Well, they can produce significant moisture increases up the Gulf of California, and due to the topography, the semi-frictionless surface of the Gulf of California, any MCSs, MCCs, mesoscale convective complexes can initiate these. And where we're looking for development is anywhere in the Gulf of California, but even as far south as Cabo, or even south of Cabo, these things can get initiated. And why they matter so much is high resolution models don't always pick up on them the greatest. So it's important for us to track these, and it can take usually 2 to 3 days. It can sometimes be a day. And once the models finally start picking it up, you can track it really well, and it can have a significant upswing in thunderstorm activity, especially flash flooding, because it provides significant low-level moisture. And some of the more robust moisture surges can get dew points in Yuma, like up in the mid to upper 70s, which sounds crazy when you think you're in the desert Southwest, but it can happen, and that's why we watch these closely. Another thing, outflow boundaries, very, very important here in the desert Southwest. We kind of call it ping pong. When we don't have a lot of steering flow, our convection is oftentimes strongly driven by outflow boundary interaction. And this was a case from last week when Phoenix got absolutely slammed. You may have seen it. They had significant flash flooding, severe thunderstorms. There was a pretty well-developed outflow boundary that got organized. It pushed across the Phoenix metro area, and thunderstorms erupted. And then moments later, Phoenix was very busy issuing severe thunderstorm warnings. And I know there were a lot of wind damage reports and some decent sized hail across the city. So, and the reason that we utilize satellites so heavy is, if you've ever looked at the Tucson radar, there's significant beam blockage. We don't really see a lot in southern Arizona, especially in northern Mexico, where a lot of our weather can actually come from in different interactions that we have with weather in Mexico. And so we rely on the visible infrared at night, the nighttime microphysics, and various other products to be able to see these outflows, because it can have a significant impact on our weather. These outflow boundaries, we've seen them travel hundreds of miles from Hermosillo, Mexico, all the way into our CWA. They'll arrive at 3 in the morning. Next thing you know, we're issuing warnings at 3 in the morning. So that's why we really, really like to keep our situational awareness up, and we heavily utilize these tools and products available to us. So this was pretty interesting for when I moved down here. You don't think sea breezes when you think Tucson National Weather Service, but it actually occurs. They don't always produce convection, but this was a day where it actually produced convection. You can see kind of the loosely drawn sea breeze boundary pushing in from the Gulf of California, and it did actually initiate convection. And what's interesting about where that convection is forming, that is very, very dry areas. Even during the monsoon, they don't get a lot of rain. As you go down towards Rocky Point or Puerto Penasco, very, very dry. There's some marine influences that usually thunderstorms kind of die as they approach the Gulf, but today they actually formed off this sea breeze boundary. And while it rarely ever makes it into Arizona, maybe it makes it into Lukeville, Oregon Pike, on the periphery of some of our boundaries or our borders, it can produce outflow boundaries that move into Arizona that can wreak havoc, producing thunderstorms. So some of the ways we use derived data, again, I was just talking to you how Phoenix got slammed last week, and we didn't. This is a great 4-panel showing the derived data that we look at: precipitable water, convective available potential energy or instability, and then the lifted index, as well as water vapor. And you can see the thunderstorm initiating northeast of Phoenix in the higher terrain. They had good upslope flow, they had good lift. You can see the bullseye of moisture of near 2 inches of PWatts, and you can see the instability in the brighter colors. We didn't have that down in our area, and we didn't really have any thunderstorms. So this was a great way to use some of those derived, some of the derived data if you don't always trust the RAP analysis, or you can't be launching soundings all the time. And moving into thunderstorms and mesoscale convective vortices, we actually have quite a few of these. I would say if it's an active monsoon period, we can have a couple to several of these that we pick up on radar and satellite imagery a week. This was a pretty prominent one in northern Chihuahua, south of El Paso. And the reason we care is it can initiate and focus convection. You can see on the western periphery of that convection blowing up, as well as West Texas, some pretty significant convection developing, being influenced by that MCV. And this was one that occurred last year. We had a little bit of fun with it in the local office. We kind of nicknamed it the Sonoran Swirl. It came out of Sonora, and it has what appeared, not an eye, but it has what appears to be an eye-like feature. And again, very, very important to track these because of the implications they can have on our weather. They can focus convection, they can initiate convection, and oftentimes, if it's on the right side of that MCV, it can kind of cause some training where we can have some pretty significant flash flooding. So we watch these closely, and we heavily utilize satellite to monitor these, especially when they're coming out of Sonora. Another thing you probably don't think of much is the elevated mixed layer. It's quite uncommon, but it does happen. And I keep going back to when Phoenix got hit pretty hard, but that was a case where there was an elevated mixed layer. You can see there in the mid-level on the sounding, this was Phoenix's sounding at 12Z that morning, some pretty steep mid-level lapse rates. And we usually see them during transition events because we need the southwest flow to bring the drier air aloft. And then if we have residual monsoon moisture around, it can lead to a pretty impressive severe weather event across Arizona where we're issuing severes, and we can actually get large hail and some more organized convection. And that same morning, here was the Tucson sounding. Again, we did not get convection developing. We couldn't really overcome some capping that we had. But Phoenix, with that upslope in the terrain, was enough to force convection that led to a lot of severe weather across that area. So just something, that I wanted to share because it's interesting. it's a unique phenomenon, and it's very similar to how it is in with the higher terrain in Chihuahua, with the elevated mixed layer coming off of the higher terrain of Baja. And here's an example of that event. You can see in the different panels, the upper level, mid-level, and lower level water vapor. You can see the drier air intrusion at the lower and mid levels, moving into kind of southern Arizona, limiting our convection, but also on the fringe of it, where there was enough upslope flow into the higher terrain, Phoenix lighting up. And we also like to use the differential water vapor as a better way to kind of track some of these moisture plumes and fingers, like kind of as you can see one across southwestern Arizona. And moving into tropical trouble. Yes, we do get tropical systems. This is looking at tropical depressions and tropical storms that's moved into Arizona over the last number of decades from the National Hurricane Center, and we do get them. Now for Tucson, we don't really have any wind issues. Yuma can certainly get some pretty strong wind gusts, but we care about them because of significant moisture increases and flash flooding. We've had some very large flash flood events due to tropical cyclones, and what I'll share here is Odile back in 2014 caused very significant flooding across southeastern Arizona. It spared Tucson, but Cochise County had a lot of flooding. I know there were other areas that had flooding as well. And then Hurricane Rosa wreaked havoc in southern Arizona out on the Tohono O'odham Nation. Managers Dam had some issues where there was a swath of 5 to 8 inches of rain, and it shows up really nicely here and visible. And you can see the storm kind of shearing apart, losing its deeper convection, but all that deeper convection and moisture is moving into Arizona. It's interacting with our terrain, and we can have significant flash flooding. So we keep an eye on that, and actually we're watching Nora quite closely, that just developed from the National Hurricane Center today, as we're expecting a track that could be similar to Rosa. So it's something that we're keeping an eye on as we move into next week. And another way we utilize satellite imagery is there's a lack of observational data and upstream observational network. We've got, the Pacific Ocean, Gulf of California, Sonora, Sinaloa, Chihuahua, the different states in Mexico. So we use water vapor quite a bit. This was an instance where you can clearly see a disturbance moving across Baja, and the models don't always pick them up. I've had shifts where I come in and you think it's going to be a down day, and you look and you're like, uh-oh, okay. Here's a little impulse moving up in water vapor, and then everything an hour or two later, you start to have significant thunderstorms developing. So we have to keep our situational awareness. We can't always rely on the models. We have to keep our situational awareness up. We have to be looking in the Gulf of California, in Mexico, in other places upstream to watch where these impulses are coming, because of the impacts they can have on our weather with such short notice, to where we don't have enough time to always message our partners, and then we're immediately into a nowcast real-time event. And then I'll leave you with this slide. There's so much going on in this loop. We have a Gulf surge, we have dust, we have outflows. This is June 2018. You can see a significant Gulf surge event where we have the increase in winds picking up substantial dust moving into Arizona. Meanwhile, we have an outflow boundary from a complex of thunderstorms over Cochise County pushing west. So this is another great example of how we use satellite imagery. And when that dust, there's obvious impacts with health concerns with that, but also we know what's coming with that dust is a significant increase in moisture. So while we may not get the thunderstorms that evening, we'd be primed and ready with the recycled moisture from the thunderstorm complex to the east, as well as the outflow and the Gulf moisture surge to the west. So what we would be thinking is, okay, tomorrow is going to be a busy day. So I just wanted to leave you with that. A really cool image of just a number of different weather scenarios ongoing in one image. And with that, I really appreciate everyone for attending, and I'll stay around for any questions. My email is included. Please reach out if you have any questions or you want to have a discussion. I'm more than happy to have discussions. I love talking about satellite. Like I said, I used to work for NESDIS a year briefly, and working out west, we use satellite all the time. It's a lifesaver for us, especially when the models are not handling things correctly. So again, thank you.
Oh, that's excellent, Jeremy. Really good examples there. Appreciate that. Excellent presentation. A couple things here real quick. The questions for Jeremy, if you want to go ahead and type those into the chat window there, then we'll get to those. But we got a few things we'll mention first here. First of all, there'll be for some feedbacks if you want to kind of contribute to the survey. Lee has posted a link to that into the chat, so feel free to kind of provide some feedback on the Satellite Book Club. We always look forward to seeing the feedback for that. And let's see here, there's a couple other things too. In a week from today, at the same time, this will be, of course, on Thursday, September 2nd at 12 p.m. Eastern. Patrick Dills from UCAR and Bill Line from STAR will provide an update on RGB applications comment module. So look forward to that next week. And of course, if you have any questions about the Satellite Book Club, feel free to contact the Tower S team. You can contact Lee or Kashad, and they'll be able to answer any questions for you. And even anything related to configuration of satellite products, they're always willing to help. I know I've kind of talked with them before in the past and always very helpful on that. So feel free to reach out to them. But again, yeah, if you have any questions, feel free to type those in and we'll go through those. Just a couple to kind of lead this off for you, Jeremy. I thought it was really interesting. We'll have to start naming our MCVs here in Oklahoma as well. So I like that, the Sonoran squirrels. So also, to me, I was really surprised when you said mid to upper 70 dew points at Yuma. So that's pretty impressive. But I'll tell you one thing that really struck me, and I'll kind of just maybe see if you want to elaborate on this at all, was you mentioned the use of high-res water vapor and potentially really that helping for tracking some of these subtle features that the models don't always pick up on too well. So, I found that very interesting. I don't know if you want to comment further on that, or maybe, talk a little bit about how that process works or how often you see that.
Yeah, so there's been a number of shifts I've come in, and you think it's going to be a down day, and maybe even in your satellite interpretation, you missed something, or there's some days where we're even looking for anything, because maybe the high-res models have things going crazy and you're like, okay, what's going on here? And then you're looking and being like, maybe you think you see something, or it's the flip side of the high-resolution models doesn't really have anything, and then you get slammed. We've seen it in the winter. We've seen it pretty much in all seasons. I didn't include all of them, but there's a number of other products we use. We use the simple water vapor and the differential water vapor quite a bit, and a number of the RGB products, because there's a lot of unique things that happen because of the topography. Another example, there's a unique feature that sometimes forms. You can get a little bit of some lee cyclogenesis in the northern Gulf of California. I've seen that in the wintertime. The models can have trouble picking it up, but I've seen it enhance some of the rain when we have frontal bands moving through, as well as, again, the outflow boundaries. You can have a significant complex of thunderstorms in Hermosillo, which is pretty far south of the border, and those outflow boundaries will track further north. And if you're not really seeing it in satellite, you can miss it, and then it comes in, and for some reason, we're primed and ready. It hits our terrain. You get a couple thunderstorms, and then we get some organization, and we can have pretty significant thunderstorms roll through Tucson and even further into Phoenix. I've seen that before. So it is imperative that we're always monitoring satellite in Arizona at all times of the day, especially during the monsoon, just because of so many different features. And I didn't show it, but another thing that can happen here is we see quite a few gravity waves. Our convection is so intense, being this far south, also having this much moisture, that we can, bust storm tops 55,000 feet, sometimes approach 60,000 feet. And we've seen significant gravity waves, and we track those because sometimes it seems to enhance convection or can initiate convection. So that's a few additional ways we also use, but I didn't really have any good examples to share today.
Yeah, that's excellent. We've found similar in Oklahoma. I know it's so valuable to be able to have the high resolution satellite. A lot of our older forecasters are really skilled at being able to interpret satellite, but it's just we're taking it to a whole new level now because we've got the increase in the bands and the RGBs and the temporal and spatial resolution is just amazing. So it's interesting to hear your perspective on that. We kind of share that here in Oklahoma. And I guess there's a couple other questions we can get to here. These holdover fire events, these wildfire events that you typically have sometimes, I know it may be similar to what we have sometimes where it crosses a burning period, but I don't fully understand those. That's kind of a new term for me, but I'm just curious, have you been able to find maybe that some of the satellite, the derived products and shortwave have really helped with that, or can you elaborate on that some?
Yeah, absolutely. And apologies, I guess I should have described. So holdover fire, what we mean by that is it's pretty common all across the West. You have it doesn't even need to be a significant lightning outbreak, but you have a lightning outbreak in some of, difficult terrain, some of the denser vegetation, you can have new fire starts. And what we mean by holdover is they kind of hold over through the night. No one detects them. They're not burning hot enough to be seen by satellite. And then the next thing you know, it gets a little wind, some solar heating, and boom, you have a fire. And you're like, well, there was no lightning there. And so that's what we mean is holdover fire from thunderstorms. And sometimes they can hold over for a couple days. And we had a lot of success in Elko with the hotspot notification and looking at satellite imagery. I know we detected fires before anyone else. And I know last year and maybe even this year, they've had some successes up there detecting holdover fires and letting their dispatch centers know that, hey, no, there's a fire up there, and that can help out. Another use of it is when there's so much smoke, it can be very difficult to detect new fires. So that's where shortwave imagery that's not really sensitive to smoke comes in handy. And so we brought that down to Tucson, and it's worked really well. We have been able to detect a couple fires in remote locations, and we did have one such holdover event last year, the immigrant fire, where we called them up about 3 in the morning and like, hey, there's a fire there, and we're like, and we're actually really confident because we know what to look for. This is likely 15 acres or more, and they were able to respond. And it did turn out to be a fire, and it did grow to, I believe, a few thousand acres. But that was a great real world example of utilizing this new high resolution. We would have never been able to do that with the old satellite. Being able to detect fires as low as 15 acres and sometimes even smaller it's been a game changer for Western offices.
Yeah, that's really good information. That's and that kind of leads into another question, but let me just quickly remind anybody that does have any questions related to this, feel free to type those into chat, and then we can ask Jeremy and start a discussion on that. We probably got another 10 minutes or so for discussion, but that brings me to my next question, Jeremy. I'm just curious because we've had a lot of success too with the initial notifications for these wildfires. Now we're different because in Oklahoma it's more of a grassland type wildfire, so it's a little different, but I'm just curious, what kind of feedback have you gotten from the partners on these notifications as far as lead time? We were actually surprised at some of the feedback that we got, that a lot of times before they received the 911 call that we're able to kind of detect that fire. So I know it's similar for your area because you got a lot of rural areas that may not have a lot of eyes on it too. So I'm just curious if you have any perspective on that.
So yeah, a couple things. And there would be people in Elko right now that could probably give you some pretty good information. But I know at least when we were there and we were actually asking our partners this very thing, and I kind of had a misconception myself. I thought we had to be first. I thought if we weren't first to detect it, what's the use? And then when we talked to our dispatch centers up in Nevada, they let us know, they're like, no, that's actually, there's more to it. Sometimes when we get a phone call, someone's driving along the interstate and they don't even know what mile marker, and there's like, I see smoke, it's north of the interstate. They have no idea. Then they get the notification from us and they're like, oh, okay, now we have a lat lawn, and now we have confirmation that it's probably a wildfire. Or when they're responding, it gives them confidence, like, oh, okay, this is a fire. This is not just a smoke report. Here in Arizona, the feedback was, so we had a few false alarms. We only had like 2 or 3, so I was worried, like, okay, are they going to be worried about that? And they actually came back and said they're not worried about false alarms. We're like, this is our job. We get false alarms from the public all the time, but they're happy with the product. When I asked them if they would like to continue it, they said absolutely, anything that could help. But so yeah, just some interesting feedback, and that really struck me the feedback that we got from Nevada, that they were utilizing it completely different than how we intended it. But it really makes sense. They were using it more of a confidence factor.
That's a really interesting point. I didn't even think about that, but I know some, talking with a lot of the 911 dispatchers, they have that problem a lot where people don't know where they are and they're not able to pin it down, but yet, so they may scramble to know exactly where to go, but yet then we could kind of come in with a little more precision. So that's a really interesting point. Yeah, that's definitely good. It's been a game changer. Our partners, in Oklahoma, I know they've been very thrilled with what we've been able to do with that. So it's good to hear that you've received similar feedback there. And I'm curious too, how do you all staff for these events? Maybe it's a bigger fire weather day. Do you dedicate somebody to the hotspot notifications, or how do you handle that typically?
So if we don't have a large red flag event, it's kind of just, our general situational awareness. We always strive to be looking at satellite. We also utilize a tool, I think it came out of Goodland, that auto detects, and it will send us an alert, and then we kind of QC it. So we utilize that tool. But when we have large red flag events, or we have dry lightning, maybe we don't necessarily staff someone specifically for that, but we try to make it an emphasis in our operations.
That's really good. Yeah, we've even went so far as to say in some situations we almost treat it like radar operations for severe weather, because essentially you have somebody dedicated to it. They're really immersed in the data. They don't have the distractions from anything else. They can really focus on the 3.9 and the other satellite products to make those notifications. So
yeah, absolutely. I mean, we look at fire weather as severe weather, and I know a lot of offices, I think, look at that in the West.
Yeah, absolutely. It happens fast, and yeah, you have to be on top of it, no doubt. Yeah, that's good. I think Jordan may have a question too. If anybody else has any questions, feel free to drop that in there. But I guess before we go to that, I'll just say one thing too, that, obviously a lot of what you talked about kind of ties in with the mesoanalysis. There's been a lot of emphasis in the Weather Service, it seems like lately or in the last year or two, about how important that is to do exactly what you described. I feel like you've summarized almost every possible mesoscale problem that you all could have, and we've been similar with that. We're trying to really push forward with that. So probably more of a comment than anything else, but just to say that, mesoscale analysis really is important.
Yeah, absolutely.
And all right, let's see here. When it comes to identifying subtle features of interest that are not well resolved by high-res models, such as mid-level shortwave impulses and jet streaks, have you been able to anticipate the GOES air mass RGB imagery? So I guess the question would be just that RGB, the GOES air mass, have you gotten much use out of that for these type forecast problems?
So I haven't used it as much in our monsoon operations. I do want to incorporate it more, but where I've utilized it more is during the winter time, especially with some of our stronger storm systems with tropopause folds, and looking at that potentially unstable and the warmer stratospheric intrusion air. Yes, we have utilized that because as these systems dive south, when they drop down through Southern California and down into Baja or Sonora and hang out for a day or two and then move north, sometimes the models don't always handle it well. So utilizing the RGB air mass is helpful in the wintertime, but I have not really used it much during the monsoon. And it kind of goes back to, you hinted at, there's so many, we're immersed in this new world of data, and you kind of get your favorites and you use those a lot. But I will certainly start, I think it's a great question, and I will certainly start paying attention here over the next month and see if anything starts popping up. But I've always used it more of a wintertime application.
Okay, yeah, that's great to know. And yeah, that's right. I mean, it seems like we're just there's so many products to go to, and the training that's been coming out has been great, but it takes a while to kind of get the experience of and exposure with these different type of events, I think. And just one quick shout out to a lot of the folks in the satellite. I know they've really helped us in our office to be great resources to go to if we have questions. And that's been a big help. So just kind of wanted to make a shout out to several of the folks that are involved in the satellite programs to help us in operations with that. So there's one other question that come in here. It looks like, are your fire monitorings and notifications part of a formal IDSS product for your fire responders and EM customers, or just informal individual notifications from Michael?
So the way we kind of developed it here, when we had the meetings with our dispatch center, we kept it to just the dispatch centers directly. We didn't want it going out to emergency managers, individual people, because we thought that could cause confusion, at least for down here. So it goes directly to their email account, as well as a few employees to their phone. And we found that works best. And we just want to control the information, because we were kind of worried that we let an EM know there could be a disconnect, since a lot of Arizona, it's kind of, the fire response is kind of out of the interagency dispatch center as well as the state dispatch center. And it seems to have worked well. And when we followed up again this year, we decided to keep it exactly how it is, where it's just kind of directly to the dispatch center and the dispatchers and the center managers. And I guess it's kind of informal, but it sends a notification and it pulls in weather information. It gives the lat long that you can pull up on Google, but it is a nice little text that goes to an email or a text notification that can be used.
Okay, sounds good. Yeah, I could probably go on all day long, Jeremy, with questions. I know we've probably got a few others too, but since we're pushing up against 12:45, we'll go ahead and turn it back to Jordan. I think he had a question also, and then, but yeah, we'll just see what Jordan has for concluding remarks.
Yeah, thanks, Randy. Thanks, Jeremy, for your presentation. I just wanted to point out, you've spent many weeks this year supporting fires. I was just wondering if you could talk a little bit about how the use of the shortwave IR imagery changes as you go from a new start to a mature fire.
Yeah, so as it goes to a mature fire, I use it, so I've got two different roles, two different qualifications on fire. So I'll speak to both of them briefly. As an incident meteorologist, we work closely with the fire behavior analyst. Sometimes we're really embedded in the operations aspect of it. And I have in the past utilized the shortwave imagery as well as RGBs and other products to be like, hey, you know, now it's 9 in the morning. Hey, there was just a significant increase in fire intensity activity on the northwest corner, and I'll let the fire behavior analyst know. And sometimes it's like, oh, well, you know, it's picking up, but sometimes maybe the fire is getting active in an area they weren't necessarily anticipating. So as the fire matures, I try to use it as like a situational awareness tool, as well as there was an incident that I worked with Chuck Redmond when I was training in Northeastern Nevada, where we had heavy smoke and there was a fire like 7 miles from camp and no one knew about it. It was a holdover lightning fire. We were able to detect it using satellite. We let our ops know and they were able to catch it at like 250 acres. So that's another way to utilize it for additional new starts around your, because when you're at a fire, you have it's called a TFR, temporary flight restriction, but it's like your initial attack responsibility, and any fire in that box is our responsibility. And then for an air resource advisor, I'm very concerned about emissions and modeling smoke. So if I have part of the fire getting very active and say the overnight veers did not capture that hot spot, I will go to that specific area and use the blue sky playground to model that area so I can have a better idea of emissions to help with my smoke and air quality forecast. So I heavily utilize it in the ARA, Air Resource Advisor arena as well.
All right, thank you. I really appreciate you outlining how how you use the data in different scenarios. Well, I think we're about at our time. In fact, we're about a minute over time. So appreciate you, and also to Randy for moderating today. As has already been discussed, we continue our Satellite Book Club weekly, and next week at 12 noon Eastern time, we've got Pat Dills and Bill Line are going to be giving an update on RGB applications, and hopefully we'll hear a little bit more about the fire RGBs next week as well. So until then, again, continue to stay well. Contact the Tower S team if you have any questions about the Satellite Book Club or configuration of satellite products in AWIPS. Thanks once again to Jeremy and Randy. Thanks all of you for being with us, and take care.